In this video, we're going to be going over the quiz for naming acids. And this is our part 14 video inside of chemistry, chapter 2. And in our previous video, we talked about just naming acids, both inorganic and also organic. So today we're going to go over a more quiz-like video on top of that, and also just to summarize everything about naming acids. So let's get started with this video. So first of all, let's check our understanding. So for our first practice question, we need to write the names and formulas for 2 common acids and 2 common bases. And then after that, we need to state at least one use for each of the acid and bases. So once again, feel free to pause the video and take your time in order to solve this question. So starting off with acids, the first one that we're going to take is hydrochloric acid. So it's a really common acid and it's used all the time. And the main thing that it's used for is inside of cleaning agents. And then another common acid is sulfuric acid, which is H2SO4, and is used in battery acid. And for bases, we have the first one is sodium hydroxide, and the formula for sodium hydroxide is NaOH, and it's used in soap making. And for our second base, we have ammonium hydroxide, which is NH4OH, and the most common thing it's used for is in household cleaners. So this is our first practice question about acids and bases and an example for both of them. So moving on to practice question number 2, compare characteristics of both acids and also bases. So once again, feel free to pause the video and try to solve this on your own. So starting off with the taste, acids taste sour and bases taste bitter. For the effects on the litmus paper, so acids turn litmus paper red and bases turn litmus paper blue. So for the pH value, acids have a pH less than 7 and bases have a pH greater than 7. And one more characteristic is Arrhenius definition. So Arrhenius was a person that gave a definition for both hydrogen and also hydroxide ions for acids and bases. So for this, what Arrhenius said was that if there is a hydrogen plus ion, then that means that it's going to be an acid. So if there's a base, then he said that there's going to be a hydroxide minus ion. So acids produce hydrogen plus ions in the solution, while bases produce hydroxide minus ions inside of the solution. So these are 3 different characteristics of acids and bases. And moving on to question number 3, identify 2 ways to measure pH, and then describe one advantage and one drawback of each of the methods. So 2 ways to measure pH is with litmus paper and also a pH meter. So starting off with litmus paper, so litmus paper is inexpensive, so it's really cheap, and it's also really easy to use. But the only drawback to it is that it is pretty less accurate, so you're not going to get an exact value. For example, if you were to have a pH value of 5, you're not going to get the exact value, you might have to guess around it. So you might put like something else close to 5, but it's not going to be exactly 5. And then for the second one we have is the pH meter, and the drawback to it is that because it's very expensive, but the good advantage about it, it is very accurate. So to the decimal point, it'll give you the exact same pH value. So for example, it's going to give 7.33 or like 2.11. It'll give you the exact accurate pH value of the thing that you're measuring. So this summarizes question number 3. So for question number 4, we have phosphoric acid has the formula H3PO4. So name each of the following related acids. So this are the 3 different related acids, and we need to basically just name them inside of the related acids. So for the first one, we have H3PO3. For the second one, we have H3PO5. And for the third one, we have H3PO2. So all we need to do is just name each of the following related acids. So we know that phosphoric acid is just H3PO4. So we know that one less would be PO3. So in this case, for the answer, for H3PO3, we're going to get phosphorus acid. For a second one, H3PO5, we have perphosphoric acid. And finally, for the third one, which is H3PO2, we have hypophosphorus acid. So this summarizes question number 4. And moving on to question number 5, the formula for nitric acid is HNO3. So what is the correct formula for each acid named below? So what we're doing here is just the opposite of what we did in our previous slide. So instead of actually finding the name, we're going to find the formula. So for the first one, we have nitrous acid. For the second one, we have pernitric acid. For the third one, we have hyponitrous acid. And we need to find the formula for each of these. So the first formula for nitrous acid is HNO2. The second formula for pernitric acid is HNO4. For the third one, which is hyponitrous acid, it is H2N2O2. So this summarizes question number 5. And for question number 6, which of the following solutions has a greater quantity of hydrogen plus for each liter of solution? So is it orange juice, which has a pH of 4, or baking soda, which has a pH of 8? And then explain your answer. So we know that from our previous videos, hydrogen plus is found in acids. So since hydrogen plus ions are found in acids, we need to look at the pH. So orange juice has a pH of 4 and baking soda has a pH of 8. So which one is more acidic? We know that it is pH 4. So orange juice is going to be the one that has the greater quantity of hydrogen plus. So orange juice has a greater quantity of hydrogen plus ions because it has a lower pH value, which indicates a higher concentration of hydrogen ions. So this summarizes question number 6. And for our final question, which is question number 7, so Swiss cheese and yogurt are made by the action of certain bacteria inside of milk. And the pH of fresh milk is about 6.5, the pH of cheese is about 5, and the pH of yogurt is about 4.5. So for question 1, which of these common foods is most acidic? So in order to find the most acidic one, we need to look for the lowest pH value. So fresh milk had 6.5, cheese had 5, and yogurt has 4.5. So we know that the answer is going to be yogurt because it has a pH of 4.5, which is the lowest out of all of them. For our second part of this question, does the taste of these foods support your answer to question A? And explain why or why not. So if you look at all of them, fresh milk is about 6.5. So if you were to drink exactly fresh milk, then you would basically taste almost nothing because it has almost a neutral taste. So it's almost 7. So you're basically going to be able to taste nothing. And then for a pH value of cheese, we have 5. So inside the cheese, you can't really taste anything either because it is pretty close to 7. So it's going to have a relatively neutral taste as well. And for yogurt, it's about 4.5. So the taste does support it for question A. So for yogurt, since it has a pH value of 4.5, the taste does support the answer because yogurt has the sharpest or sourest taste, and that indicates that it has a higher acidity. And if you were to taste some type of yogurts, you could taste that it has a really sharp sour taste, but after that it can turn sweet maybe, but in the initial taste it is sharp and sour. So this summarizes question number 7. And to sum up everything that we covered in this video, we talked about chemical formulas for given acids, we talked about the nomenclature inside of inorganic acids, and we also looked at how to write the formulas for given bases. So in our next video, we're going to cover over and discuss why water is weird. So that summarizes everything for this video, so thank you so much for watching from Try to Be Useful, and we'll see you in our next video.